What, Lucas, you have a question or no? Okay, Lucas. Lucas
I
don't
was
have.
just wondering if you were gonna post the solutions to the quiz after
Yes,
the.
I will be. Okay.
Okay.
Later today, I'll post the marking scheme, everything. Okay, Lucas.
Okay. Thanks.
Okay. Good morning. Uh, Today we are going to deal with two topics. Uh, the last on bending. We have looked on bending since week 1 on Friday. Okay. So we're going to do the last topic is eccentric unsymmetrical bending. Then we are going to look into shearing stress. Shearing stress is new. This is chapter 6 on your textbook. Okay, it's new. We have not seen before. Probably if Dr. Koshi did teach you guys some shearing stress. An introduction. Okay, we are going into more into depth. Okay, just to remind you, Friday, January 28th, lectures will start at 8:30 to 9:20, and then lecture again at 10:30 to 11:20. Okay, I need the extra time for the lecture so far is because one, we have the snow day, but two, there are topics that I need to elaborate more to you. Okay, quiz number 2 is due on January 29, which is on a Saturday, 2359. So from this week onwards, all your quizzes are due on Saturday. Okay, so do your homework and do the quizzes. I've marked some of the quiz, especially quiz 2. Some of you did not really grasp the concept. Okay, it's fine. Okay, I will post the marking scheme so you know what. Look, you have a question.
Yeah, I just wanted to confirm, because you mentioned doing the homework before the quiz. The homework 2 lines up with quiz 2, right? And homework 3 lines up
Yes,
with quiz 3? Okay, yeah.
always. Okay,
Thank you.
I will not be unfair to you to make you do a quiz that you've not done the homework or not seen the homework before. That would be unfair. I will protest. I'll go a hunger strike on that case. Okay, right. So today's the last topic on bending, which is eccentric unsymmetrical bending. Okay, so I last lecture on Monday, I touched briefly, and I'm going to carry on where we last finished. Okay. So I want you to take note that px is not in line with the x-axis. Okay. So the x-axis I'm going to elaborate is this axis, and you see P, there is an offset. Okay, there's an offset. So we have an offset of P at a distance. So A is about the x direction. B is about the y direction. Okay, so that is the offset. Okay, so there is an offset. Okay, so for this case, we have a moment about the y-axis. Okay? So we have a moment about the y-axis. So it's equal to P times by A. Right? So that's the moment about the y-axis. Okay. So that moment over there that you see P multiplied by A, that is the moment about the y-axis. Yeah, so I'll use a different color, sorry. So that's the moment about the y-axis. Now the same concept apply that I taught you beginning of this lecture series in bending, where the head of the bending moment is compression, the tail end is what? Tensile. Okay, and then we go into the other direction. Okay, so you know that mz will be equal by so P times by B. Okay, now all these diagrams can be downloaded on the example that I've given last Monday. Okay, so if you go to this file over here, you can get all the figures. Right, coming back to our lecture. Okay, so likewise, the moment at B, okay, sorry, the moment at Z again, as you can see, if I'm going to draw the moment vector now, okay, so this is our moment about Z axis, and again we have compression at the head of the vector arrow, and below is tensor. The analysis still stand, okay, it's still valid, right? So from here, when you have a case, okay, where the load is not in line with the x-axis, okay, your formula change from stress x, okay, is equal to P divided by A. Okay, so A down here correspond to this A correspond to the cross-sectional area. Okay, then you have plus my over Iyy multiplied by z minus by mz over Izz multiplied by y. Okay, so this is the formula that we'll be using. The only difference that you see between centric and eccentric, so this case is eccentric. Okay, whenever you have eccentric, so this is for eccentric unsymmetrical bending. Okay, so whenever it is eccentric, you will still see the load over here induced by axial loading. And this is induced by bending moment. Okay. So you can see that the analysis is still the same. Okay. You have not learned anything new in terms of analysis. The only thing you have to take consideration in terms of eccentric unsymmetrical loading is that you have to consider P over A. That's it. Okay. Now let's immediately look for example. Okay, we're going to do example number 1. So this is the question. Right. So for the loading condition shown, determine the stresses at point A, at point B, the point where the neutral axis will be intersecting A, B, D. Okay. So when we start this example, we have to draw our transformation first. So I'm going to sketch our transformation. So the first one is this is our direction in terms of X. And then the vertical is our Y. And finally, using right-hand rule, this will be our z-axis. Okay, so some questions do give the transformation. Those that don't, you just have to determine your transformation yourself. Okay, so we realize that for this case, you have axial loading. Okay, so we want to find stress X. The forces are all applied in the X direction. So we know that we're going to have Px over A plus by My over Iyy multiplied by Z minus by Mz over Izz multiplied by Y. Okay. So for this case, what I tend to do, okay, I like to look at the front view, okay, or view the structure at the YZ plane. Okay, and I'll explain why we want to view at the YZ plane. Then we can determine the tensile and the compression easily. So I write down here, do not worry about the positives and negatives for the formula. Okay, do not worry about it. If you cannot remember it, fine. Okay, because as I said, I've taught you how to analyze to determine whether is it positive or negative. Okay, now let's look at PX first. Okay, let's look at PX first, but let's draw our view first. Okay, our view about YZ plane. Okay, so we're going to view this on our YZ plane. Okay, so this is Y, this is Z, and is 1.8 by 4. Okay, and then we are going to incorporate our forces. So this is a dot. It's coming up at 150. Then we have this coming at us at 500 pounds. And then we have this coming at us at 250 pounds. Okay, and then we have our rotation about X. Okay, so from here we know where is our centroid. Okay, so we sketch out our centroid. So we know that by observation, okay, you don't need to calculate. By observation, we know that these are our centroid. Okay, these are our centroid. So from here, the first thing that we do is we are going to calculate the forces in the X direction. Okay, we're going to calculate forces in the X direction. So Px is equal to 150 plus by 500 plus by 250. So this will be equal to 150 plus by 500 plus by 250, and it's going to be 900 pounds. Positive. Why positive? Is because it's going to induce tensile. Okay, this force is going to induce tensile loading. So the next thing that we are going to do is we are going to find out the moment about the y-axis. Okay, so this will be my, right? So we are going to make an assumption using right hand rule. Okay, so I'll draw for you how does my look like. Okay, so this is our moment about y. I'm going to assume that this is the positive direction. I repeat again, we assume that this is the positive direction. Okay, so for this case, now we start to say that, okay, moment about y, this is positive. Okay, so we're going to calculate moment about y is equal to, so we take the 150. The 150 is going to induce anti-clockwise about the y-axis. Okay, so it's 150 multiplied by 2. Why multiplied by 2? Is because the distance from here to here is 2 inches, and the distance from here to here, okay, is 0.9 inches. Okay, And likewise, the distance from here to here is equal to 2 inch. Okay. And then the next one that we will look at is the plus by 500 multiplied by 2 inch. The 250, we're going to induce a moment in the counterclockwise direction. Okay, sorry, in the opposite direction from what we have drawn. Okay, so this will be minus 250 multiplied by 2. So now we have moment about y. This is equal to 150 times 2 plus by 500 times 2 minus 250 times 2 is equal to 800 pounds. So positive. Okay, and this direction is valid. Okay, it's correct. So when that's the case, immediately write down based on my, we're going to see a compression, and then this end we're going to see a tensor. Okay, then the next stage,